Welcome to our experiment, performed by Caroline, Vicki-Lee, Aimee, and Rhys. The focus of our experiment is to explore how the rotation of the Earth and its relationship with the Sun creates shadows that change in length and direction throughout the day. We would like to find out why shadows change throughout the day and how the Earth's rotation impacts the shadow's position. Our predictions are: I think the shadows will be longer at lunch because the shadows on the basketball court are really long at lunch. I think the length of the shadow will stay the same, but the shadow will change positions throughout the day. I think the shadows will move because the sun moves across the sky. And I think the shadow will stay in the same spot because we are not moving the stick. For this experiment, each group of 3 students will need an icy-pole stick, an A3 piece of paper or a paper plate, blue tack, a pencil, a compass, and a paperweight. The first step is for each child to choose a role: the timekeeper, the engineer, or the scribe. The timekeeper keeps the time and makes sure that every hour a measurement is taken. The engineer assembles the experiment and makes sure it's in an appropriate spot, and the scribe measures and records all of the evidence. The engineer collects the equipment and chooses an appropriate spot to assemble the experiment, ensuring that there will be plenty of sun and it won't be in the way of other students. The engineer then uses the compass to mark north on the piece of paper and making sure that the experiment is facing that direction. At 10 o'clock, the timekeeper reminds the group that it's time for their first measurement. They go to the experiment and the scribe traces around the shadow and marks the time on the piece of paper. It is up to the timekeeper to remind the group at every hour it's time to record another measurement. At 11 o'clock, 12 o'clock, 1 o'clock, 2 o'clock, and 3 o'clock, the whole group goes out and the scribe traces around the shadow and marks the time on the piece of paper. At 3 o'clock, the last measurement will have been recorded. It is time to bring the experiment inside and for the scribe to measure the length of each shadow and write it down on the piece of paper. This is the end of day 1 of the experiment. At the start of day 2, each group should double check the measurements for the length of their shadows. Next, the group should work together to record their results onto a table, as modelled by their teacher. Each student should then use their table of results to create a bar graph on grid paper to show all the different measurements lengths of the shadows. Students then compare their graphs to other students in their group, and then to other groups to see the similarities and differences and if there are any trends in the data. The class then comes together as a whole to discuss their results and create a group graph of the whole class results. We found that the shadow of our stick moved in an anti-clockwise direction from west to east. The length of the shadow was longest at the start of the day, shortest at the middle of the day, either at 12 o'clock or 1 o'clock, and grew longer in the last few hours of the day. To conclude our experiment, we found that the rotation of the Earth causes the Sun to appear to be moving across the sky. At the start of the day, the Sun is low, and this causes the shadows to be long. At the middle of the day, the Sun is at its peak, and the shadows are at their shortest. As the Sun descends, the shadows lengthen for the rest of the day. Thanks for watching.